Students, in our last class we have just started the reflection of waves. We have seen that when a wave travels from a medium, what happens after getting incident on a medium. We have seen what happens to that ray, and I was citing some examples to make your concepts clear. Okay, so two examples I have introduced. Okay, now let us see that we all know that if a light falls on a mirror, what happens? Obviously, it will change its direction. Okay. So these phenomena, that means the two phenomena that I've introduced in the previous class, are all examples of reflection of wave, though the nature of waves are different in different cases. Okay. So more or less we have seen that what happens that when a wave travels through water, and what happens if you stand and clap after from a large wall. We have seen these two examples, and from these examples our basic concepts of reflection of wave is more or less done. Okay. Now again students, I will go back to the previous diagram that I've put in my board, this diagram. Okay. What is this PQ? PQ is the interface of the two mediums, or a reflector is being termed for this PQ. Okay. So in PQ means, that means since it is separating the first medium and the second medium, so we are terming it as what? A reflector. Because when a ray travels and it strikes this interface, it gets back to the previous medium or to the opposite direction. So that's why we are terming it PQ as your reflector. Clear? And O, this point O, see, this O is the point of incidence. AO and OB are the incident ray and the reflected ray respectively. See, I've also written it. This AO is your incident ray and OB is your reflected ray. Okay. Now, what is left with us is your NO or ON. Okay. So let me introduce this particular thing. The perpendicular ON on the reflector, this is your reflector, drawn at the point of incidence O, that means it is drawn at the point of incidence O, is called as the normal. I hope this term normal you have also learned while studying the chapter reflection of light, isn't it? Okay. So I am writing it here also. ON is the normal. Okay. At the point, I am not writing point of incidence O, I am just writing it as at O. Alright. Okay. So the angle between the incident ray and the normal is called as the angle of incidence. That means this one. This one, that means angle AON is your angle of incidence. I am writing here angle AON is your angle of incidence. Students, I am writing this as, okay, I am writing it full. I hope you all know the symbol of angle. Okay. So angle AON is your angle of incidence. Okay. See, this I have also marked as I. Okay. So similarly, what will be your angle of reflection? The angle of reflection is the angle between the reflected ray and the normal is your angle of reflection. That means this one, NOB1. Or simply you can also term this from your diagram. You can also write it from your diagram. I am not writing it again. Okay, because these are all the basic parts Hope you have done in your junior classes. Alright. So now students, obviously like the laws of reflection of light, you have learned there will be laws of reflection of waves. Okay. So similarly like the laws of reflection, your first law of reflection of wave is the incident ray, the reflected ray and the normal, that means this one, to the reflector, that means to the this one, to the interface at the point of incidence lie in the same plane. I hope if you can recall that your first law of reflection of light was this only, isn't it? So similarly we will use that law here also. So what will be your second law? The angle of incidence, that means angle I. Let me write it here. Angle I will be equal to angle R. Okay, that means the angle of incidence is equal to the angle of reflection. Alright. We have learned in today's class the laws of reflection of light. But if you just think a bit, the two laws of reflection of light, in these two laws of reflection of light, in these two laws of reflection of wave, only the path of ray, this ray, just imagine this path of ray, that is the direction of the wave motion, is described. If you just go through the laws once again, you will see that only the path of the ray, that means in which the wave is moving, suppose the wave is moving in this direction, only this path is only being described. Okay, but these two laws do not give any such idea regarding the changes in properties of the wave. Okay, due to reflection. Are you getting any idea regarding the changes in the properties of the wave? That means if the wave, how the wave is being affected or not, or if any properties are changed or not, would you able to see? The answer is no. Okay, so let us learn some more rules regarding this reflected ray. Okay, so your rule number 1 is like this, that due to reflection, velocity, wavelength, time period and frequency of wave do not change. That means what are the three factors? Reflection, due to reflection, velocity, wavelength and time period and the frequency of wave do not change at all. Okay, so that means these four things, that means velocity, wavelength, time period and frequency, remains unaltered.